shortly to me, my name is Engin Diri. I'm working as a customer experience architect at Pulumi, working mainly here with customers in the post-sales area if they already onboarded. I like to do everything cloud transformation, cloud enablement, and continuous everything. I started my whole continuous stuff with cruise control using and Java, so this time around, and then went all the way up here now to nowadays stuff using Tekton on Kubernetes or whatever to build and deploy your stuff. Before Pulumi, I worked in a company you all know because I saw there is a store here. I worked for the Schwarzgruppe, which is the people behind Lidl and Kaufland. So if you always go to a Lidl or Kaufland and buy some stuff, it's the IT we worked on and enabled. So very cool to see also stores here. Okay, so short introduction again about the whole infrastructure for AI part. So AI, everybody is probably sick of this and it gets up and down everywhere. Generative AI and AI stuff is very cool. And what we find out now, that most of the business, or not even every business, can benefit from AI. So I made here some short list here about some stuff, some areas where we can say some benefits to put in and say where AI could help in the healthcare here for personalized treatment, marketing. I mean, marketing, it's a big thing, getting some campaigns running with AI, the data, sending out stuff, and so on and so on. So we can see that AI is here to help different areas, and if we embedded AI, everybody can benefit from this inside our company, independent what are you currently working on. And there's also a phrase from Mike Glennon, which I found also very nice. He's a senior analyst at IDC. He says, companies that are slow to adapt AI will be left behind, independent if they are large and small. So this is the phrase from him. And I found this, if you look back now, the last couple of months with all the announcement, you will see there is something going on. So everybody from Amazon, if you go to amazon.com, Rufus, you have an AI assistant and you can ask about products and he gives you information about product, to even smaller stuff. And even us, if you go to pulumi.com AI, we have also now, since last year, we have also an AI product where you can ask in natural language, for example, I want to create an S3 bucket, I want to create an EKS cluster, please give me the code. So you have different options from Terraform, YAML, whatever, and it spits you out because everything is embedded to our documentation, and it delivers value for bootstrapping, for quickly getting your project done. So everybody is using AI to boost their business, and nowadays you even get easier venture capital when you have some AI products. So this is also a reality that everybody in the startup world, in the tech world, try now to add AI because they want also to get some VC capital, because VC venture capitalists, they're looking for this kind of specific enhancement into an existing product. Okay, so we know everybody needs AI, everybody wants to run AI, maybe they already started locally or using ChatGPT, for example, creating there some specific stuff, and we find out that AI needs infrastructure. And now we come to the point where we say, okay, if we want to implement, for example, AI, we run quickly into some of the challenges here, for example, when we want to use on-premise infrastructure, because it's very costly to purchase, to scale, maintain. It's difficult to integrate, and all the things which are attached to running now this new kind of workload on maybe on our existing infrastructure. I also mentioned this because I mentioned also coming from, for example, from the Schwarzgruppe. Larger enterprises have still the requirement to say, okay, we cannot send out everything to some proprietary LLMs, for example, because we don't know what happens with the data. Either we have to invest much into anonymizing some of the informations, or we just ignore them and not allow them. So some companies, they have a policy that their employees are not allowed to use any AI stuff from one of the vendors, for example, or from Claude or from ChatGPT. But then again, running this stuff with a local AI or with an open source AI on premise infrastructure, you come to this point, and this is something you probably guessed it. So extend our statement and say, okay, AI needs infrastructure, AI needs cloud infrastructure. Because now we see also, where is it not working? Okay. if we, for example, use cloud infrastructure, now we make again the bridge to the all AWS stuff, because probably the hosts of this evening, they're like, why are you talking about on-prem and so on? I'm AWS. Yes, we find out that most of the major free cloud providers now offering nice packages to you to run AI workload for us very easily. So for example, if I want to run an open source GPU powered LLM, for example, Llama or whatever system there is outside what you prefer, you may need to create an EKS cluster with GPU nodes on it to run the workload there. So you can see it makes sense, because maybe you cannot access the GPU stuff and so on to build this on premise, but now you can do this in the cloud on AWS, and you get the benefits of pay for what you're using. You have storage, networks, everything's created for you, and most importantly, you can easily up, down, and out scale depending on your needs. This is really something which makes sense. Some of the points are still valid for classical workloads, so it's not that we invent now the wheel completely new. But yes, if I had classical workload bring to the cloud via lift and shift or via dedicated movement to a cloud provider, I would benefit from this. But now with AI, then the specific needs for the infrastructure, it makes even more sense. So AI goes very well here with cloud infrastructure, because we can leverage some of the points. Okay, and again, this is another point. It was during KubeCon Paris, Solomon Hykes made a nice keynote talk about a specific topic, but then he had this slide in where he quickly mentioned also the whole AI movement. This was at the beginning of this year. And he says, at the end of the day, AI factories are just cooler software factories. Yeah, because underneath it's still some hardware. We always think has to be something specific or some crazy stuff. No, at the end it's still a VM or a GPU specific stuff. So, but it sounds interesting, it sounds fancy, and I like this very much to say, yeah, we need still our classical infrastructure provisioning to now handle AI specific workload. Okay, and now we come to the next point. We know we need infrastructure, we need infrastructure in the cloud, and we come to the point, yes, AI needs also infrastructure as code, because independent of the tool you are using, Terraform, Pulumi, or Bicep, or CloudFormation, you need infrastructure as code to run the stuff, to quickly create new instances, to change stuff, to have everything provisioned. So all the benefits they told you once about using infrastructure as code also applies for AI-specific infrastructure. And now we come to the point why I'm here, Pulumi. But I just want, before I jump into some kind of Pulumi, let me also add another point to it, because we live in a time now where the phrase platform engineering is also very important. So AI needs also platform engineering. So the last thing I'm going to summon today to say, okay, what AI needs, platform engineering. Because we come to the point that nowadays folks would like, because of speed and availability and all the things, they say, I would like to be able to provision now the AI infrastructure in a self-service approach for my platform engineering team, because I'm a developer now. I'm going to create with LangChain or Llama Index or whatever system I'm using to create my AI workload. I need now a specific infrastructure, and the platform engineering team now needs to be capable to say, okay, I'm going to create, the so-called golden path, this package where you can just come to our platform. I now mentioned Backstage, for example. You come to our internal developer portal, you provision your AI-enabled whatever you want to order, an EKS with GPU power or whatever. And also we have the data scientists who also needs access to this stuff. So we see self-service is a very important place, because everybody wants to quickly deliver, and nobody can maybe provision everything from scratch, because maybe they don't need which GPU we want to use or not. So creating them a specific platform or extending your existing platform for AI-specific golden paths is completely beneficial. So okay, now we come to Pulumi. That's the last point. So I'm not going to bother you now too much, as I mentioned before, about how to write an AI application and so on. So I work at Pulumi, and we provide infrastructure as code. So what is Pulumi? Again, I would like to keep this short and not everything else you can look up into our documentation. So Pulumi is a modern infrastructure as code tool. I will go into details what we mean with this. One of the advantages is when you use Pulumi is that you can just use your familiar programming language and tools. So we support Python, we support .NET, Go, and TypeScript. So you can just continue creating the story that could be beneficial in different scenarios, from you build it, you own it, you run it, to platform teams who would like to create bigger stories. We work with any major cloud provider, so you have providers for AWS and co. And now comes the important part, because we all know what happened a couple of months ago, and everybody is now more aware about licensing. So Pulumi is open source. You don't need to buy anything. You don't need to bring out your credit card. If you want to try Pulumi, just go install the CLI and you're good to go. And then you handle the state files on your own. If you are like, okay, I even don't want to get bothered with handling some state files and so on, we also offer a cloud where we have a free tier, and you can just continue working with me. For example, all my demos I do with my free tier. So the companies always ask me, why you're not using our organization inside our own product, because you can use everything. And I'm like, hey, the free tier is very good. I can use this stuff there. Okay. So a little bit more detail what we mean with using familiar languages and using the tools of your choice. As I mentioned, Pulumi is supporting YAML, Go. My example is with TypeScript I brought here. You can use .NET. This is very interesting for all the Azure people, because 100%, no, let me not say 100%, 70% when I have a question coming from somebody using Azure, I can be sure that they're using .NET, because somehow this works very well together. And then Python. And here come again to the data scientist. We find out that all the customers coming from an ML background, for example, and they do this kind of ML stuff, they have strong Python knowledge, and they use, for example, Python to then provision the infrastructure. So everything is there. And you can use the IDEs of your choice. I work with some engineers inside Pulumi. Once they shared the screen with me, and then he had the VI, you know, it was like, wow. And he programmed in VI. I have no idea. I'm a noob, so I use IntelliJ, used also before Eclipse, so I like this. Sometimes I use VS Code. So as you can see, you can use what you want. Package manager of your choice. Yes, if I use TypeScript, I could use Artifactory. If I have a company restriction, to use only approved packages, or I could use NPM or PyPy or whatever package manager we are using. The middle thing is where the meat is, where you can build now stories to say, okay, I have a provisioner for AWS, and I have also, for example, New Relic, or I have Datadog. So I can now create a story creating an EKS cluster on AWS, using the Kubernetes provider, as you can see, to deploy instantly an agent of Datadog and then provision Datadog. So you can see I can create a end-to-end story, and that's why it's important to have a huge variety of different providers. And then Pulumi doesn't tell you how to use it. So if you're using Jenkins, for example, you can install the CLI in the way you are used to provision your worker nodes, for example, and make it accessible. Or you can use Azure DevOps or whatever tool to integrate. So Pulumi is not telling you you need this specific tool or whatever. So from the famous shift left, use what you are used to use in your everyday work, up to the deploy process for the DevOps teams. Okay. A short, very, very short introduction on how Pulumi works under the hood. And this is most of the time where people are like, oh, that's so boring. But sometimes I have some engineers who are very interested into the nits and grits of Pulumi. So again, also, why you're not working? Okay. So everything starts with a Pulumi project. The moment you install the CLI, either through NuGet or through Brew, depending on what system you are using, the moment you install the CLI and you type Pulumi new, for example, it will spin up a so-called project. A project is a folder where we have our Pulumi YAML file inside, defining which runtime we are using. So this is this field here. And then Yeah, it's a little bit not good that it's not visible. So then we have the system so-called stacks. So if you're coming from an AWS world and used to write with a CDK, you may be confused with the term of stacks. We mean with stacks environments. So you could create a new stack called dev, and then you can configure everything inside your dev stack. So think about Pulumi stacks are similar to environments, and now you can think about this. You can override now values. So if you set a config value like my EKS cluster has always 6 nodes, but for dev I don't need this because I just want to approve some stories, you could override the node size of your EKS cluster to 1, and yeah, the closer you go to prod, you maybe extend the stuff. So this is the possibilities with the stack part. We have customers who use now stacks also to create ephemeral environments, so it doesn't have to be named like devQS, and so it could be also alphanumerical because they are short-lived, and then you destroy them again. The Lego building blocks are the resources, and as you can imagine, every resource has input and output values, and you can use the output from one resource as an input to another resource and then create the story. In the background, what Pulumi is doing in the engine part, depending on how you write it in your imperative language, that's very important. So using now an imperative language, it will create a graph in the background with all the dependencies. So when Pulumi find out, it can create, for example, the security groups of a security the rules of a security group, it can maybe process them in parallel, doesn't need to wait that some other resource is finished. But for example, if I want to create a subnet in AWS world, I have to wait that the VPC is created if I'm not using the default VPC. And then you can imagine it either creates the dependencies, everything which can run parallel runs in parallel, and then you gain some speed benefits here. Pulumi is talking directly to the API, so it doesn't compile into some CloudFormation YAML files. It goes directly there and then communicate with the cloud provider API. Good part is, but this is again some advanced topics, I'm not going too deep into this, is you can use input and output on a project level. What is it necessary? Think about your database team has now the task to create a story to provision databases. They can create now a Pulumi program and have only input values where people can tweak around. They can say, okay, I need maybe a high available database cluster, so maybe this is a flag I want to set before I execute the Pulumi code, and this is something you can do. And as an output, you maybe get the URL and the username and password. Okay, that's again Pulumi architecture. I will jump over this. So we have our CLI. We write our code here in the JavaScript here, for example. It starts a gRPC-based microservice, the so-called language host, and then detects on the language I'm using what he has to start, and on the resources I'm creating, which provider it has to download. So it goes to GitHub, for example, downloads the AWS provider, starts this also as a service, and then communicate and say, hey, create, delete, update, and every operation, oops, I'm now a little bit too quick, and every operation gets then saved into so-called state file. The next time I run again a change, it will compare this and say, okay, there is only a change here, or there is a deletion, and then just make the delta actions, for example. So as you can see now here, so Pulumi, that's what an engineer also said this funnily, he said Pulumi architecture is actually a microservice architecture which accidentally runs on localhost because everything gets executed, started, and then communicated via gRPC. So if you want to write your own provider, you just need to implement our gRPC stubs. Okay. There are much more things to discover. Of course, it's not the only thing in our tool suite, so we have different levels. We call this our platform for platform teams. I'm going to focus in this part only on the Pulumi IAC part and on the providers, mainly the AWS provider, but you can check policy as code is important, Pulumi ESC, and so on. So how does it look like in action? So I made now a SageMaker model example here, using VS Code. And in Go, this is the Go code you write. For example, if you want to deploy your SageMaker stuff, the IAM stuff is a little bit up. And yeah, typical Go, you have all the error, if error stuff. Same code running in TypeScript, for example. So that's literally the same code. And here you see the IAM roles. And then the same one in Python. And now comes the interesting part, and this is a big YAML written, because sometimes people are like, hey, you're supporting YAML. Yes, we are supporting also YAML. This is, for example, how Pulumi would like in YAML, and that's a very cool stuff. I like this very much, so it's very cool to see the same code or the same output I would like to have in different languages. Okay, so here is something missing now. There is a slide missing. So I would like, before we head over to the demo, because there's so much to cover here, I would like to show you 3 topics I found interesting if you're interested to see if Pulumi is a fit for you beyond the typical I create the infrastructure. So what are some of the advanced topics I like very much? So stack references. I mentioned this before. I can create now different stacks here, my infra stack, my Kubernetes stack, my application stack, and now I can map this, for example, to Pulumi projects with their own environments. And now what I can do now is, for example, if I created now my infrastructure stack with the subnets and all the stuff set up, I can now export all the things needed for the next team or for the next thing I'm working, that people, for example, can now deploy a Kubernetes cluster. So, for example, we know an EKS maybe needs access to a subnet and all the information. So I can create this in infra. I can export the subnet IDs via the output of my project. And then the Kubernetes project just references to the stack. And this is called with the so-called stack references. And now you can go the chain completely up. You can say, okay, the development team, for example, they need just a reference to the kubeconfig file because they want to deploy some Helm charts on top of it. So the people in charge of the Kubernetes cluster, they export, for example, only the kubeconfig. And the people can then reference, for example, to the Kubernetes stack in the production environment or test environment, and then deploy their applications on top of it. And with this, we now created a nice separation of concern. We can create now also different responsibilities. So we can say, okay, the infra team is different, the Kubernetes team is a different team, but people can communicate via the stack references and access, and cannot accidentally delete, for example, infrastructure, or don't have to ask themselves the question, how do I set up a subnet and all the stuff? How does it work? What do I have to think of it? Because we can now rely that the infrastructure team around the networking and so on, they created the base infrastructure networking setup for this account with the best practices and compliance in your company. So stack references are a very good tool to separate this, to have not a huge Pulumi program running over everything from network down to the Kubernetes cluster, separated. And if there is a change, I can only run, because we know the velocity of the development team is maybe quicker. So they're going to all the time integrate, run stuff when they commit new code. This will be executed much, much quicker. But a subnet, I mean, to be honest, when you create a subnet, it's created. You're not going to change much on this. So you don't need to check every time on it and say, hey, is there any change? And then you wait. So we have sometimes customers who work with a older setup where they everything created from top to down in one Pulumi program. They wait up to a half an hour on this because they have to ask now, is there a change? Is there a change? So we highly recommend, for different reasons, to say, if you have the chance for a greenfield program, think about how to cut your Pulumi program, your infrastructure program, into different pieces, being velocity or separation of concern. Abstraction. I mentioned this several times with golden paths. Abstraction is something everybody loves and hates. We support this abstraction part also. So you could now create, for example, your perfect EKS setup, and people can use, for example, NPM to download the specific component resource in Pulumi, and they can just embed this in their code. So if a team needs, for example, a Kubernetes cluster, they make import from in TypeScript, for example, and then just fill out the API contract and get everything provisioned. This is also a very cool functionality to share and to give people the best practices, to not let people start from scratch. And we support this in two ways. As I mentioned, the component resource, these are resources for language specific. So if your team is only working in TypeScript or your company only working in TypeScript, just use the TypeScript way of creating a component and then upload this to PyPy and let people know, hey, this is version 1.0 on how we create a Kubernetes cluster. Please use this. Or you have maybe some kind of cookie cutting going on or bootstrapping via Backstage or your internal system. So when they order, for example, a Kubernetes project, it could automatically use this component and just bootstrap everything. So they don't even need to know how where to find the stuff. You say, okay, everything is already set up here. And we also support Pulumi packages, aka multi-language components. So you could write your abstraction in one language and automatically generate SDKs for all other languages. This is very useful if, for example, your company is polyglot. The ML people use Python, the front-end people use TypeScript. You could say, okay, let me create a Kubernetes cluster definition and then spin out all the SDKs for the different languages, and I'm 100% sure that I reach everybody because the front-end people can also use this because they know only TypeScript, and you can then build up your platform engineering story very cool because people don't feel like they have to change their way. You can just say, hey, I have it for you in TypeScript. So a very cool feature. And last but not least, automation API. It's always like, hey, is this an API I have to curl or whatever? No, it's actually a library. So it's an automation API library. And what gives you this possibility, so this is the classical way: you download the CLI, you run Pulumi up against the cloud provider, either as a person, don't do this in prod, or as your CI system. And with the Pulumi automation API, you have now the ability to programmatically execute Pulumi code inside a web service. So you could create, I worked, as I said, for the Schwarz group, and there was a change. The rule was every team has to expose their service as an API to Apigee. So everybody had to sit down because we wanted to enable every new team or everybody inside the Schwarz group with the possibility to create new touch points. So the database team had it now to expose their service, creating day 1, day 0, day 2 operations as an API in a huge catalog to look up for the people. And now you can imagine, if I have to do this, I can use now Pulumi with the automation API, create a endpoint with, or create an event-based system where I use Python, for example. You can create your own CLI. We have customers who created huge CLIs and exposed them internally for developers to provision ephemeral work dev environments. And you could create your own ops workflows with GitHub Actions, for example, or whatever you need, and everything inside the code. I use it, for example, I created the Backstage plugin. Backstage is using TypeScript, and I use the TypeScript implementation of the automation API to execute Pulumi code inside Backstage. Okay, and there's much, much more. So I mentioned automation API, deployments, Copilot, again, more embedded AI in our Pulumi cloud offering. Backstage I mentioned. We now also launch Pulumi EAC, secrets management, configuration, all in the cloud, in our cloud offering. So yeah, feel free to try this out. It's free, as I mentioned before, so no credit cards swiping needed. And now we come to the demo, because everybody will say, okay, your talking is cheap. Let's see how does it work. So let's see if this is working fine. So let me switch like this. So where are you? Come on. Okay. Oh, perfect, perfect, perfect. Okay. So, okay. I mentioned this several times, um, and I can't see a thing. Let me put this here again and system settings, and let me mirror my screen. Otherwise, I will not be able to do this. So, um, okay. So mirrored. Um, I created with Pulumi new now a basic project in TypeScript. I mentioned before the Pulumi YAML with the runtime defines what it has to use. I can choose which package manager and so on. So this is something created. And now I have here my index file. Oh, wait. Oh, sorry, I forgot something. Um, just before, okay, high level architecture I wanted to show. So left side, the platform engineering team, I'm going to create a VPC and then I'm using an ECS with Fargate enabled, so an Elastic Container Service from AWS. I use a Elastic Container Registry to upload my container there because Pulumi is also able to use to create a container image using the Docker provider. I'm going to provision an open search service also, or I already did because it takes ages to provision this, and an application load balancer. And what's happening now, the development team, this is something I will show you, can create now via the provider the image. It gets automatically uploaded to the ECR instance I created, and later a user can then call this application and put markdown files. It gets indexed via the RAG capability of the LangChain into the OpenSearch cluster. I'm using Claude as Bedrock, AWS Bedrock with Claude as the LLM in the background. And then it can ask my documentation and say, hey, I'm going to blah, 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 looking for something. So this is the setup I just wanted to quickly show. So let's head into the code. So this is completely written in TypeScript, and as you can see now here, I created now the ECR repository. This is the registration around this, some little registration part, but here is the Docker build part. So what I'm going to do now is, because I have here a folder called app where my application, it's a Streamlight app, you will see this also later in action, provided with a Docker file. I also have a local Docker Compose where you can execute this locally and just play around if you want to develop. So it's really try to replicate actual workflow. So development team works on this, can create the stuff, provided a Docker file. So now we're going to deploy everything as I mentioned before. So tell here Pulumi to build now this image, providing some informations and some specific build arguments I put into my Docker file. I say the cloud provider is AWS. I say just build Linux because my ECS instance doesn't have any Graviton support or whatever. I don't need a specific ARM-based image, and then getting some of the information. That here we can see output from one resource is the input for another one. Because I don't know the ECR repository URL, I'm going to use this as an input, and also the secret part. So that's one part. Here, creating the VPC, the security groups. I will quickly jump over this because it's really getting the informations done. Here we have now the domain. If I, for example, need now to create more domains, I could just use here my my for loop. I have a GitHub Copilot installed, but as you can see now, I can use the benefits of the programming language. I can create now some of the syntax. I can have a if, I can get the data from a database, whatever I'm using. So it doesn't have to be simple put down like I did here now. So using a for loop does the same. If I need, for example, to create 2 domains and then getting the values dynamically here, in this case, I just need 1 domain, a simple small domain. Here I created the ECS cluster. setting the capacity, security groups, all the stuff. So at the end of the day, if I scroll down, the application load balancer, the listener, the task roles, and then all the IAM policies like, hey, go to Bedrock and everything. Um, the task definition. So as you can see, there's a lot of ground to cover here where you can really create a dedicated workshop for everything. The idea is I created the definitions, the IAM, everything is up and done. I can deploy this now via cookie cutting or via self-service. The development team maybe get this setup already pre-created. They have the apps folder, they have this set up, and they can just now start to program, open the app stuff, go into their code, and set up their whatever they would like to change here. So here's everything in the code here. Let me just go here to my code. Where was it? Here, as you can see, here I created now the LLM. In my case, I'm using Bedrock. The Mistral here on Bedrock using US East 1. This is something you can hard code. You can use configuration to provision this. And then I'm going to use here my vector storage here, the open source search as my vector storage. Okay, all set up. How does it look like in if I want to execute this? Locally, you can use OIDC, for example, to connect. You can use your token. So there are also different ways to connect with your system. Your prod environment can set up using a CI system and so on. Again, you don't need to run this on your local machine. It's just for demonstration purposes. Now I'm logged in, and I can now use the command. Strangely, IntelliJ doesn't allow to enlarge this here down, so it's a weird thing. Every time I get people are angry with me because they're like, can you make it larger? No, it's not possible, this one. I can run now Pulumi up, and because I'm already created the instance beforehand, because it takes a lot of time to create an open search, managed open search cluster, but I can check again, is there any changes? So in my case, because I did not change anything, there will be no changes. So that's now the internet effect, the demo effect. But yeah, he's going now and checks, is there any changes? Let's have a look. How does it look like in our Pulumi cloud offering? So so we can see here also what's going on in the backend. So that's the same output we see in our CLI, for example. But here I see a little bit more information: who did this, which process is running, and then we can see here what is it doing at the moment. And as we see, oops, nothing is changed. So I did not change any setup. We can later also make a demo to see how it looks and change. But as I said, I created some outputs here because I would like to have my URL of the open search because my application needs to be addressed. So here in this case, I just copy paste now. And let's head over to the application itself. And this is now the Streamlight application I deployed on our system. So here we can now activate here, use rug. And now I can drag and drop a file into it. So I created a demo file. This is really everything demo about New York. So you see the top 30 tourist highlights of New York. And I would like to extend now the Mistral AI with some specific informations about my service. I just wanted to come up with an example. So you could use your Confluence pages. You could use whatever you want. So let's look this also up. Where are you? Workshops, here you are. And let's head over to our New York. And we say load. And hopefully nothing breaks. So it's running and it's now indexing the stuff. and creating all the embeddings in our LLM to find the informations. You can swap a little bit with the chunk size and the overlaps and so on. And hopefully, yeah, hopefully everything is loaded. And to see, let's ask a simple question about the Central Park to say, okay, where is the Central Park? So we expect now that it goes directly to our information and doesn't come up with some things. So we say, where is the Central Park? Really made up example on this again. So it says the Central Park is located on the 59th to the blah. So let's see if this is true. Yes. Oh, 110. And it says 110. Yeah, it's definitely from the code. And let's ask about the description there to see that it's really coming from here, that it's now enhanced with the information. How we ask this, describe what is at the Central Park. So let's hope again that it goes to our informations. So Central Park is an 844-acre urban oasis, blah, 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 with strawberry fields. So now we look into and strawberry fields from John Lennon Memorial. So it gets the informations out. So it dropped, as you can see, it dropped the information, but added here, which serves as a memorial for John Lennon. So the AI does this AI thing, but with the data we provided him. And this is also the part where we come into topics like hallucination and so on. Even if we provided him as much as information, it still has sometimes the liberty to change stuff. This is something we also fight here with our Pulumi AI sometimes, to keep the hallucination as low as possible, working with temperatures and all the stuff. But this showed you it's working. It gets the informations out of our markdown file we just provided, and everything is working as accepted. Okay, so what happens when we have any changes? This is also something quickly to show. So let's head back to our Pulumi program and say now, for example, I'm not going to execute this, but to show you that there is a diff to our, here, we say now we would like to have 2 clusters in our domain because there is a change and there's something we would like to do. So we can now execute Pulumi up again. But I don't want to apply this. I just want to have a preview. This could be useful for a CI approach to see any changes, to give an alert, for example, if there's a breaking change. But think about this. You did not create now redundant system. You accidentally changed the stuff or did not thought about this and just apply. Some resources has to be destroyed to recreate, and then you may have a downtime. So running a Pulumi preview and seeing what's going on is very useful. In this case, we expect now an information around the domain. So, and when you make a demo, it always takes ages. So we see there is a difference. There will be an update. If I want to see more details about the difference, I can also say, hey, give me a Pulumi preview with the diff, because I would like to actually see, because maybe the person who changed it is not the same person or the system to execute the stuff. So now it gives you an output of this. So we see now here, yeah, it's the cluster config is changed from 1 to 2. And now I could decide or automatically decide, hey, this is something I would like to do or not. As I mentioned, we have also policy as code. Then you can, for example, lock this down and say the developers and all the CI systems, you are never allowed to change the instance count to anything else. And last but not least, also on the side of the application, for example, we had a spelling error. We call it now rec parameter. And again, make a Pulumi preview because we instructed Pulumi to build the image. We see now a difference also in our container, and it should also execute this stuff and give us also information that is going to build the image from scratch. Not from scratch, at least going to recreate the image. So we see there is a difference in our context. So it's going to build the image again, and because of the change of the image, because there will be a new tag now, it's going to update also the task definition of EC2, because here there will be the change here. So what I mentioned before, Pulumi detects the connections between each resources, and if there's a dependency in one of the Pulumi resources, for example, in the task definition, if I scroll down in the task definition, where are you, task definition? Here, we see the image is the output of our image build with the digest and all the stuff. And yeah, makes sense to recreate. And then when you recreate the definition, everybody who worked with ECS knows recreated of the definition can, if you set it up like this, automatically deploy a new deployment in ECS, and then you get the new version out. Okay, so yes. Yeah, that goes to the Pulumi cloud. That's the Pulumi cloud one. So I use Pulumi cloud. Um, yeah, if you want to use Pulumi cloud, then you can use the UI. That's all part, as I mentioned before, of the free tier. So if you like to use the stuff, if you say, hey, I want to self-host the backend on an S3 bucket, I don't want to, I am not allowed to use a cloud service in my company, you don't get this. So you have several options, as I mentioned before. I'm using here the cloud thing, but as I wanted to present you also the OSS part, I did not mention this now in particular, but yeah, this gives you now an auditable thing. Now you can create um, teams. So if you go for a professional setup, so this is my private organization, I mentioned this before, I use this mostly, but if you go here into a real organization, you can set up OIDC, teams, and all the stuff, you know, everything which you need to be enterprisey. Okay, so let's head back to the slides, and then I'm finished also. Whoop. So we saw how it helps you. This is just a short snippet on the AI infrastructure. Most people are now using EKS with a Carpenter, for example. So they say, okay, our company doesn't use any of the services like ECS and so on because we are outgrowth of this. They provision an EKS cluster, install Carpenter, and then they detect the workload with labels and say, okay, if I deploy an application with the label AI, it's provisioning under the hood a specific EKS node with a GPU installed. And if the node, for example, has an auto scaling, and nobody is using it at night, for example, the EKS cluster will scale the workload to 0, and Carpenter will detect that there is no workload using anymore the GPU instance, and also shut this down. You see, you can really go clever stuff. So, but again, it's also possible here. Okay. Q&A, I know it's much, and I'm an engineer. I could put 200 things into this to show you some cool stuff. But yeah, any questions?
Time for 1-2 questions. So, there is any questions on the audience? Okay, give one moment. We need to record your question.
Thank you. Do you have like any API to unit test this code that you were showing?
Sorry?
Do you have any API to unit test the code that you were showing to create infrastructure?
Yes, you can test the Pulumi code also. That's our own chapter. If you mean how to, is there a way to do integration tests, unit tests, and so on? Yes, you can use the stuff the language is providing there, and then work with this. I again jumped over this. Yeah, one of the benefits.
Do you offer any proprietary API to support with the unit testing, or only what the language
what
offers?
the language is offering. So there is no dedicated stuff to say, hey, you have to use this specific stuff. So if you're using, for example, now I came up with what is currently people are using, some test runners or whatever, you can use this, continue with this. That's very cool. So some companies, one of the reasons they also like to switch to Pulumi or use Pulumi is because of the testability stuff. So from unit testing to integration testing, and then they see, is there any breaking things or any problems? Yeah, that's possible.
Okay, thank you very much.
I'm a developer, I don't test. So straight to prod, YOLO. Okay, so Somebody told me that it's good to have CTA. I learned this. It's a call to action, and you should never leave without any call to action. So yeah, feel free to try Pulumi at home, even if you cannot fit this in your current workplace because you're set to a specific thing. Try it. It's always nice to upskill yourself. And join also our Pulumi Slack. There are all the engineers. If you're interested to talk more geeky about our own AI stuff and so on, join the Pulumi Slack. And if there's no any questions, I'm going to leave now the place. So thank you very much, and thank you.